The ocean depths, a realm of perpetual twilight where sunlight barely penetrates, creating an eerie, otherworldly environment. Here, the crushing pressure is so intense that it can easily collapse unprotected vessels, yet it has long captivated our imaginations and driven us to explore. Down in the abyss, hidden beneath the waves, operate some of the most technologically advanced vessels ever created: submarines. These incredible machines are designed to navigate the most inhospitable environments on Earth. These underwater behemoths, often cloaked in secrecy, play a crucial role in exploration, defense, and scientific discovery. They are the silent giants of the deep, moving with purpose and precision. Imagine a metal leviathan, longer than a football field, gliding silently through the deep. Its sleek design allows it to cut through the water with minimal resistance, making it almost undetectable. Submarines are marvels of engineering, capable of withstanding immense pressure while carrying a crew and sophisticated equipment. Inside, the crew works tirelessly, monitoring systems and conducting research. Their ability to operate submerged for extended periods makes them ideal for a multitude of tasks, from military patrols to underwater research. They can stay hidden for months, gathering crucial data and intelligence. Submarines hold a certain mystique. Their silent operations and hidden missions add to their allure, making them a subject of fascination and speculation. They operate in a world hidden from our view, their missions often shrouded in secrecy. Whether it's a covert military operation or a scientific expedition, the details are rarely disclosed to the public. Yet these underwater vessels are crucial to our understanding of the oceans and our planet. They help us map the ocean floor, study marine life, and even monitor climate change. Join me as we delve into the fascinating world of submarines, exploring the science and technology that allow them to conquer the deep. We'll uncover the secrets of their design, the challenges they face, and the incredible feats they achieve. The defining feature of a submarine is its ability to control its buoyancy, seamlessly transitioning between the surface and the depths below. This remarkable capability allows submarines to perform a variety of missions, from stealthy reconnaissance to deep-sea exploration. This feat is accomplished through the ingenious use of ballast tanks. These tanks are strategically placed within the submarine's hull and play a crucial role in its operation. These large compartments within the submarine's hull hold the key to its underwater acrobatics. They are designed to take in and expel water, which directly affects the submarine's buoyancy. Think of a submarine as a giant metal fish with lungs. Just as fish use their swim bladders to control their depth, submarines use ballast tanks to manage their position in the water. When these lungs, the ballast tanks, are filled with air, the submarine becomes buoyant, like a ball floating on the surface. This is because air is much less dense than water, making the submarine lighter. To dive, the submarine needs to become denser than the surrounding water. This is achieved by replacing the air in the ballast tanks with seawater. This is where the ballast tanks come into play. By opening valves, seawater is allowed to flood the ballast tanks, forcing the air out and increasing the submarine's overall density. As the tanks fill with water, the submarine becomes heavier, and like a stone tossed into a pond, it begins to sink beneath the waves. This process is carefully controlled to ensure a smooth descent. The ability to control buoyancy is not just about diving and surfacing. It also allows the submarine to hover at a specific depth, which is essential for various underwater operations. Controlling the amount of water in the ballast tanks allows the submarine to fine-tune its buoyancy, achieving a state of neutral buoyancy where it neither rises nor sinks. This delicate balance is crucial for maintaining stability and maneuverability underwater. Achieving neutral buoyancy is like finding the perfect balance point. It allows the submarine to remain suspended in the water column, conserving energy and enabling precise movements. This capability is vital for tasks such as surveillance, research, and even rescue missions. Navigating the underwater realm requires a different breed of propulsion. Unlike surface ships that rely on wind or powerful engines, submarines must generate thrust while submerged. Two primary types of propulsion systems dominate the submarine world: diesel-electric and nuclear. Diesel-electric submarines, the workhorses of many navies, employ a clever combination of power sources. On the surface, diesel engines roar to life, generating electricity that charges massive battery banks. This stored energy then powers electric motors that drive the submarine's propellers, allowing it to move underwater. Nuclear submarines, on the other hand, possess a nearly limitless range and endurance thanks to their onboard nuclear reactors. These reactors generate immense heat, which produces steam to drive turbines, in turn powering the submarine's propellers. Nuclear submarines can remain submerged for months, limited only by the endurance of their crew and food supplies. Section 4. Defying crushing depths, the strength of double-hull systems. Venturing into the ocean depths subjects a submarine to immense pressure. The weight of the water above exerts a crushing force, threatening to crumple the vessel like a tin can. To withstand these extreme conditions, submarines are engineered with robust double-hull systems. Imagine a submarine's hull as a layer cake of steel. The outer hull, exposed to the ocean's pressure, is designed to be incredibly strong. Beneath this protective shell lies the inner hull, providing a safe haven for the crew and sensitive equipment. Between these two hulls lies a void, a space that can be filled with water or air to control buoyancy. This double-hull design not only provides immense structural integrity, but also adds an extra layer of safety in case of a collision or underwater explosion. Section 5. Navigating the abyss, sonar's role in the deep. In the inky blackness of the ocean depths where sunlight fades into perpetual twilight, submarines rely on a different kind of vision sonar. This technology is indispensable for navigating the mysterious and often perilous underwater world. Without it, submarines would be virtually blind, unable to traverse the deep ocean's complex and varied terrain. This remarkable technology, short for sound navigation and ranging, allows submarines to see their surroundings by emitting sound waves and interpreting the echoes that bounce back. These sound waves travel through the water, and when they hit an object they reflect back to the submarine. The sonar system then processes these echoes to determine the size, shape, and distance of the object. Think of a bat using echolocation to navigate a darkened cave. Just as bats emit high-pitched sounds that bounce off objects and return to them, submarines use sonar to map their surroundings. This comparison highlights the natural world's ingenuity and how humans have adapted similar principles for technological advancements. Submarines emit pulses of sound which travel through the water, bouncing off objects in their path. These sound pulses can travel great distances, allowing submarines to detect objects that are far away. The ability to send and receive these sound waves is crucial for the submarine's navigation and safety. By analyzing the time it takes for these echoes to return, the submarine's sonar system can create a detailed picture of its surroundings. This process involves complex calculations and sophisticated software to interpret the data accurately. The resulting image helps the crew understand the underwater landscape, identify potential hazards, and plan their route accordingly. Sonar is essential for a wide range of tasks, from mapping the ocean floor and locating underwater mountains and trenches, to detecting other vessels and navigating through treacherous waters. It can even help in search and rescue missions, finding sunken ships, and studying marine life. The versatility of sonar makes it an invaluable tool for both military and scientific endeavors. It's the submarine's eyes and ears in the deep, allowing it to operate effectively in a world devoid of light. Without sonar, the deep ocean would remain an impenetrable and dangerous frontier. Thanks to this technology, submarines can explore, navigate, and perform their missions with confidence, even in the most challenging